Hello everyone, today I am going to tell you about real number part 3. The two parts I have already discussed about the real numbers. Now this is part 3. How can we recognize whether a number given is an irrational number? So to recognize the irrational numbers, I have classified into three types. First of all, pi is always an irrational number. Any number which is non-terminating and non-repeating is also an irrational number. So you can put the numbers in haphazard manner and you can get an irrational number. You can see that no numbers are repeating at a given regular intervals. 1 0, 1 0 0, 1 0 0 0, 2 3 4. No numbers are repeating at regular intervals. So it is an irrational number. 3 0 2 1 9 8 7 6 3 2 9 6 5. No numbers are repeating at a regular interval. So it is also an irrational number. Third part, root 2, root 3, root 5, that is the roots of a prime number or a simplified root of a number which are not perfect squares or cubes. I have found here root 8. Root 8 can be written as 2 under root 2. So again it becomes the square root of a prime number, therefore irrational number. Cube root of 16 can be written as 2 into cube root of 2. Again it is an prime number, so that is why it is an irrational number. So here square root of 8 and cube root of 16 are irrational because we are not able to find it's a perfect number. That is, we cannot simply simplify to get it out of the roots. Results on irrationals. Let p be a prime number and a be the positive integer. If p divides a square, then p also divides a. This rule has to be followed in order to prove that a number given is an irrational number. Here we are going to prove root 3 to be an irrational number. So we always prove a number to be irrational by method of contradiction. We will assume that let root 3 be equals to a upon b, where a and b are integers which have no common factor other than 1. That is, a and b are co-prime. This implies a equals to root 3b. Now we will square both sides. So a becomes a square and root 3b becomes 3b squares. A square equals to 3b squares. So 3 is a factor of a square. This 3 becomes factor of a square. So 3 is also a factor of a. Now we will assume a to be 3c. So this becomes a square equals 3c square, 3c whole square equals 3b square, or 9c square equals to 3b square. This implies 3c square equals to b square. So from 2, 3 becomes the factor of b square. So 3 is also a factor of b. Therefore, we arrive at a contradiction that a and b are co-prime. Therefore, our assumption that root 3 is a rational number is wrong. Hence, root 3 must be an irrational number. So we have to write all these lines in order to prove that a number given is an irrational number. In similar way, we can prove other numbers also to be irrational. The only change we need to make is to substitute a. You can see here I have already substituted a equals to 3c. A equals to 3c. So here also we have to substitute a with the same integer whose square root is to be proved an irrational number. Example, root 5 equals to a upon b, where root 5b equals to a. This becomes 5b square equals to a square, or 5 is a factor here of a. Now substitute a equals to 5c. That is what I have explained here. Or b square equals to 5c square, or 5 is a factor of b. So 5 becomes a common factor of a and b. There are 4 types of sums that are asked regarding the extended irrational numbers. One is addition form, 2 plus root 3. Other is subtraction form, 2 minus root 3. Third is multiplication form, 2 root 3. And fourth is division form, root 3 by 2. All these types of irrationals are proved by the method of contradiction. Example, in all cases we need to separate the rational from the irrational. First sum, let a upon b equals to 2 plus root 3, where a and b are co-prime integers. Now bring all the rational numbers on the one side and the irrational numbers on the other side. On solving, we get a minus 2b upon b equals to under root 3. So our assumption that 2 plus root 3 is a rational number is wrong. Therefore 2 plus root 3 is an irrational number. In the same way, we are also going to prove the subtraction form of irrational to be rational. Let a upon b equals to 2 minus root 3, a upon b minus 2 equals to minus root 3, a minus 2b upon b equals to minus root 3, or by bringing this minus, this gets interchanged, this becomes 2b minus a upon b equals to root 3. So the left hand side becomes rational and the right hand side becomes irrational. So our assumption that 2 minus root 3 is a rational number is wrong. Therefore 2 minus root 3 must be irrational. Let's come to the product form. A upon b equal to 2 root 3. So this 2 you bring down, it becomes a upon 2b equals root 3. So this becomes rational and right side becomes irrational. So by same method we can write that 2 root 3 is an irrational number, because our assumption that 2 root 3 is rational is wrong. Now we will come to division form. A upon b equals to 2 upon root 3. Now root 3 you bring on the left side and the other numbers you bring on the right side. And we can see that root 3 is an irrational number, where 2b upon a is a rational number. So by method of contradiction, again 2 by root 3 becomes an irrational number. So this is all about irrational numbers. We will see in next video about the polynomials and how we will recognize which polynomial is to be solved and how it is to be solved and what can be their graphs. Thank you.